analysis pipeline that we are discussing. Part 2 was about the acquisition, part 3 was about preparation, and the third stage is data analysis. Okay. So here we'll be looking at into analyzing the data for distributing, or you can say for presentation purpose, okay, or to visualize the data and to see what the data is saying to us, okay, or to listen to the data. So here we use a term called data voice. Data voice is nothing but what the data is telling us. Okay, after we prepare the data, we visualize it, or we see this data, we analyze the data to see what the data is telling us. Okay, for example, let's say that I have collected the data from a supermarket to visualize the sales in some specific period. Let's say, for example, the sales of milk products during the month of Ramadan. So during the month of Ramadan, what is the sales of milk products? If we want to analyze it, we arrange all this data, okay, arrange it in terms of months, the data which is related to the milk products, okay, what is the sales and what is the purchase, what is the sales, and so on. So now the numbers will tell us that how much is it, there is an increase in the sale of milk products in the month of Ramadan, for example, or if we consider any other specific period of time. So after we prepare the data, we analyze it, we listen to the data, that what the data is saying that to us, okay, what the data is telling us, so that based on that we can take some actions. We can take some actions, we can do some preparations. Okay. So analyzing, that is finding the data voice, finding what the data is telling us, what the data is giving us. Fine. So our path through the data analysis pipeline seen so far is acquire and package the data from the external source, that is acquisition, then clean and prepare it for analysis and reporting, that is a preparation. The next step here is the analysis of the data. So the prospective analysis step is that we do analysis for from we look at this analysis from two perspectives, which is descriptive analysis, inferential analysis. Okay, both is both constitute ways of finding data voice, what the data is telling us. Okay, descriptive analysis explore the data to bring out its basic features, isolate any of these features that might be of particular interest. Okay, so descriptive data is from what the data is telling. Once you prepare the data, you do some analysis steps to see what the data is telling us, what the data is giving us. Okay, what details we are getting from the data. For example, if you take the supermarket data, we can see what is the sales, what is the purchase, which product has the higher sales among other products. This is all the descriptive analysis. The second thing here is that the inferential, which aim to go beyond the descriptive and to bring out new ideas from it, such as to confirm some hypotheses that we make, to make comparison between sectors of the data. Okay, to confirm the hypothesis, let's say that we make the hypothesis that due to the month of Ramadan, there will be increase in the sales of milk product. To confirm this, we analyze the data and we find that yes, due to this month of Ramadan, from last 2 or 5 years of data, we can confirm that this is because the sale is high in this month only because of the month of Ramadan, or people keep fasting. Okay, so we can make a hypothesis is that people are keep fasting. Okay, then there will be high in the sales of milk products, and that in that hypothesis also we can confirm again here. Okay, So two perspectives of analysis, which is descriptive and inferential. Most of the form of data analysis consists of transforming the data in summary. In case of both of these approaches, we look at some of the standard ways in which data set can be manipulated to support the analysis, to assist the decision making, and to generate information and insight of the data. We'll build on techniques presented in the previous section, which is in the data preparation, and we will also consider some techniques which is also used in data preparation. Okay. Now, the role of statistics in analysis. Analysis is not complete in some cases without statistics, okay, without being used as numbers. Fine. So whether this is true or not, much of the data analysis is needed numerical and numerical analysis. Okay. Uh, Indeed, much of the analysis is numerical and numeric analysis, except some form of analysis does not use numbers. Otherwise, we see that most of the analysis use the numbers. Okay. The same example of supermarket, if you want to analyze the sales and purchases, that you analyze in terms of numbers. What is the sales? What is the purchase? Is in terms of numbers. You want to confirm the hypothesis, like during when the people fast, there is this increase in the sales of milk product. So this hypothesis you confirm by numbers, like what is the increase, what percentage of increase in sales of milk product. Okay, so statistics definitely plays a role here in analysis, in data analysis. Sharing analysis results. So why we do the analysis, at the end we want to share these analysis results with the concerned parties. Okay, so we produce the results after the analysis activity. We produce the results that can be reported on and shared with others. This is most often achieved by using visualization, by using some graphs, for example, the bar chart or pie chart. Excuse me. Okay. So visualization can be used here in reporting the results of analysis. So this visualization we can present in the form of figures, okay, or it can be presented in other forms, okay, which were more helpful in understanding what the data is saying. So let's start with the descriptive analysis. Descriptive analysis seeks to describe the basic feature of data in a study. This is to describe the data's characteristics in shape in some useful way. What are the characteristics of the data, the shape of the data, okay, in some useful way to understand what the data is saying. One way to do this descriptive analysis is to do the aggregation, that is, aggregate the data. That is, if the data consists of elements on an interval scale, to boil down the masses of data into few key numbers, including certain basic statistical measures. Into you just bring down to few numbers so that we can easily see those numbers and we understand. We can see and understand. Like for example, you bring the count of numbers. For example, what is the sale of milk? Bring the count. That is 100 bottles of milk are being sold, or let's say 100 liters of milk has been sold. So bring this count, or bring the average, or bring the sum as total. That is an aggregation. That is an aggregation of the functions. Compressing the data in this way runs the risk of distorting the original and losing the important details. Nevertheless, descriptive statistics may provide powerful indicator for decision making. So a second way of describing the masses of data is using visualization technique, that you put all the data in a form of figures, in a form of graphs. That is by visualizing. Okay. Now, in descriptive, what we said is to do the aggregation, that is aggregate the data. Okay, so simple aggregation, for example, if you take the aggregation of the data, let's say we have two tables. One is a table that is representing an OU module, fine, taken by a number of students. TX987 is the module or the course taken by a number of students, their marks, their gender, their age. You can see here. This is the course code, student number, student marks, age, and gender. This another imaginary student overall script of a student, one particular student. What is the module, number of credits, and what is the marks in that course, in that module. So student has taken a number of modules, their credit hours, and the marks taken by the student. So now we can apply the aggregation functions on these. What aggregation functions we can apply on these tables is that, for example, we can make a count, which is a number of values in a set or a list. For example, number of courses taken by the student, or we can say number of students taking the course, taking the module TX987. Okay, or we can do the aggregation of sum, that is the total of the values in a set or a list. Or you can find the maximum value, the largest value, the minimum value, or the smallest value in the set. Or we can also find the average, which is also mean, the average of the course or the average of the marks scored by the student. But these are the aggregation function. So commonly provided in data processing and analysis packages. These aggregate functions are commonly you can find it. SQL also provide these aggregation functions. Python pandas provide these aggregation functions. Okay, so if you're using SQL, you can also use these aggregation functions. Okay, in Python you can use these aggregate functions, okay, to aggregate the values. So what about the null? What about the null? For example, here we have an example here. Let's say, forget about the null. We do here example of select the count of module code and as how many modules, sum of credits, total number of credits student taken, average of marks as average marks from transcript. So what this will do? It will count the number of courses taken by this student, this transcript, the sum of all the credits taken, and the average of all these marks. Okay, this is all aggregation. So it will generate you this result. How many modules the student has taken? 13 modules, a total of 365 credits, and the average marks are with the average of 49.25 marks. Okay, now in this case, we need to see what about this null value or a null marker, a null flag, whether this will be considered in the aggregation function or not. In SQL, the nulls are ignored. So it will not count as 13 values. If we count these are the 13 values. Okay, but due to null, the average function here will ignore this null and consider only 12 values and calculate the average based on the 12 values, ignoring this null value. Okay, so different different packages or different database tools consider this differently, but most of the time commonly these null or the flags what we studied in the part 3 are ignored. Okay. Aggregation in data warehouse, that is on online analytical processing activities, also use this aggregation fine to keep the data as an aggregate data, as to keep it in once in the data warehouse instead of every time you take the data you calculate this aggregation. So data in data warehouses, basically these are kept. Okay, we'll see that in the coming parts when we discuss about data warehouse. Then we have cross tabulation, also called cross tab. It is a process used to reveal the extent to which the values of categorical variables are associated with each other. That is how the values are associated with each other. This will be okay, checked in cross tabulation. The result of cross tabulation is again a table which is called contingency table, also known as cross tabulation frequency distribution table. So cross tabulation will provide you some aggregate values or some aggregate values that will help you to see how the variables are associated with each other. Okay, for example, you just take this table which is of capital revenue data for each directorate, okay, with their transaction numbers. Okay, so every directorate here in the ministry will have some revenue and some capital, okay, with the transaction. And what is the transaction? So a cross tabulation can be generated for this to see the total number of capital and the number of revenue by each directorate. What is the count of revenue, the capital and revenue by each directorate. So in that case, what we do here is that we just count it for each directorate. For children's service, capital is 37, count, and revenue is 4091. For community welfare, capital is 30 and revenue is 5039. Similarly, for corporate, it is 3628. Okay, for economy and environment, and for resource and for resources, it is 44 and 1092. So this is by using aggregation. We use this by using the count aggregation. We use this cross tabulation. Further, this can be also be extended to see the total of every directorate in terms of capital and revenue, as well as total of all the directorates in terms of capital and revenue. Okay, this can also be checked here. So you can see that every directorate what it has in capital, in revenue, and in total what it has, every directorate. Right. This will also help you to analyze the data if there is any mistakes or if there is something is missing in the data. Like for example, you look at this number 64 and look at the other numbers. All the numbers are in 3-digit, whereas this 64 is in 2-digit. Okay, sorry, all the numbers are in 4 digits. All the numbers are in 4 digits, whereas this corporate has only 2 digits. So meaning that there is something mistake here. There is some mistake here. With the analysis, with this analysis, of cross tabulation, we can understand that the corporate, there is something wrong with the corporate capital or revenue. Okay. Further, we can analyze that yes, there is something wrong with this revenue of the corporate. So whether it is just 28 or some number is missing here. This is also a very helpful here in understanding that. Okay, in cross tabulation. So this is what a cross tabulation is. So cross tabulation is a process which is used to reveal the extent to which the value of a categorical variable are associated with each other. Okay. Further, statistics for descriptive analysis, there is more powerful statistics measure that summarize the properties of each variable separately. And techniques such as univariate analysis can be used here to see every properties of every variable in the analysis. Right. Three main characteristics of single variable generally, which is distribution, central tendency, and dispersion. Distribution, basically how the values are distributed can be seen in a form of a graph. For example, if you take that, let's say for example, a student marks, okay? So if a module is large and we plot each possible marks against the number of students who achieve it, the normal distribution will be a bell curve. So it is in the case that the module is large and it has a good number of students, then the curve what we are expecting is a normal distribution. In a normal distribution is a bell curve. Okay, as you see, meaning that there are students, there are poor students, there are average students, and there is a high, very good students. Okay, this should be, should be analyzed in this fashion. Should be analyzed in this fashion. Okay, the normal distribution will be in this form. So the same thing can be put it here in a form of a bar chart. Okay, so the distribution like a student scoring 1 to 10 and a student scoring 91 to 100. Similarly, students scoring 11 to 20 and then 21 to 30. So if overall you can see that a small bell curve you can see. Fine. So it's a normal distribution, right? In real life, we may not get this normal distribution. Then we need to skip this, or we need to bring this to a normal distribution. Okay, in terms of, for example, in terms of grades, like for example, we see that most of the students fall behind the average. Most of the students are falling behind the average, meaning that so we can make a decision like, okay, there is something wrong, some problem do exist here that says that brings in this graph. So how we can skip that to bring that into a normal distribution. Okay. Then central tendency, very few students will get marks far from average from this. So statisticians tend not to be interested in this. Okay, so most statisticians are more interested in what is happening at the middle of the distribution, that is at the center of the distribution. So most of the time, what we look here is that what is happening here. Forget about this. Okay, forget about this. These are exceptionals. But most of the time they see this part, that is the average part. So what is happening here? How the students are doing, how the average students are doing here. Okay. So in that case, we'll measure mean, median, and mode. And the mean is known as the average, okay? And the median is the middle value of the set of values, and the mode is the frequently occurring values. So if these are the marks, then the mean is the average, okay, average of these, and the median is the middle value, which is 20, and the mode is frequently occurring. Frequently occurring value is 15 here, for example. So in this example, 15 is the mode, and there may be greater than one mode value. So if the values appear only once, they're all the mode values. Okay. The mean versus median. Median is the middle value, okay, whereas the mean is an average value. Whereas the mean is an average value. So here we see the mean and median. What is the difference between the mean and the median? So if in a normal distribution, mean is equal to the median. Mean should always be equal to the median. There should not be high difference between the median and the mean in a normal distribution. Okay, but if we say that there is a difference here, that difference is the big thing that need to be analyzed, that need to be understand the problem between the distance here between these two values. Okay. So it is almost like 16. Here is the distribution, here is the 16. Dispersion of dataset is an indication of how spread out the values around the central tendency, how the values are distributed, or how the values are spread around this mean, on the sides of the mean. Okay, so whether the values are equally distributed or not equally distributed. Okay, if the mean is 50 for marks between 0 and 100, then what are the values that are distributed between the on the both the sides of 50, whether they are equally distributed or not. The common measures of dispersion is the range, the variance, and the standard deviation. The range is the highest value minus the lowest value. So here in our example, the range is 84. However, this is little used because of an outlier. We can widely exaggerate the true picture from here. Okay, because here it is not a good curve here. It's not under a normal distribution. So this is the range, the variance and the standard deviation. The variance and this standard deviations are measures on how spread out around the mean values are the accepted measures. So no need to worry about how these are calculated. Fine. So we are not doing all this in calculations, how we are going into these calculations, but I'll just show you that the variance is again the differences. Fine. And the standard deviation is the differences between the mean and the median. Okay. So this should be minimized. This should be minimized to bring in all the data or into a normal tendency or into a normal form. Okay, so this is one way of measuring the data or analyzing the data in terms of numbers. Okay. The next is correlation. Correlation here is one of the most widely used statistical measure. A correlation is a single value that describes how related two variables are. How two variables are related. For example, the relationship between the age and the achievement of OU model. Okay, with the hypothesis that older students tend to do better in TX987 module. So here, generating a correlation between the two variables, that is the achievement and the age, or you can say the marks and the age. These are two variables. Okay, now you generate a relationship between these two variables based on the hypothesis is that the older students, the student who has the higher age, will get good marks in this course. So the first step is to produce a scatter plot of age against the marks in this data set, okay, which can be something like this. So the ages and the marks, and you can see the plot here that, so with this, you can say the ages with the low ages getting the low marks here, okay, and with a high age getting the high marks here, fine. So this data tells us that, fine, the student with a high age are getting the higher marks. The student with the low age are getting the low marks in the course TX987. Fine. So this generating a relation between these two variables, age and the achievement, are the marks that the older students do better in this course. Okay. Interpreting this plot, there is some kind of positive relationship between the age and the marks. There are two questions: strengths and significance. What is the degree of this relationship? In other words, to what extent these two variables are related? Significance is that, is the relationship is real or is just a product of chance? It's not real. It's just by chance it appear like this in this data. Okay, this is the significance. The two things we need to understand here from this plot is that whether this strength and the significance. Okay. So we'll stop here for today, and we'll continue from this correlation analysis in our next meeting. So we left no time here for today to complete this. So I'll just stop here for today, and inshallah we'll continue in the next meeting. If you have any questions, please you can ask. Okay. Tomorrow, inshallah, we'll try to complete this part 4. Okay. CLMS is not functioning. Please keep trying this. It may get, get in, inshallah, very soon. But if not, we'll try another solution. Okay. So just keep trying this week. Hopefully, they're just gonna fix it as early as possible. Okay. So inshallah, you will get it in 1 or 2 days, and then you can work on it. Recording will be there here in the chat box. Anytime you can get in and access this recording. No need to post this on LMS and all. Whenever you want, you just get into the chat box of this meeting, and you can access the recording. Okay, your attendance will be marked automatically here in the system. It will be recorded automatically. So I'm not going to take any attendance here, but rather we'll have that as a report from Microsoft Teams. So don't worry about it. As long as you are attending, your attendance will be there.
Can we leave now, Doctor?
Yes, you can leave. If you don't have any questions, you can leave.